Okay, guys, welcome to the first session, and we're about to become experts on Java 8. Please welcome Nicolai Parlog.
Hey everybody, hi. And also hi to the internets, because this is apparently streamed, which is part of my first public service announcement. So we're live streamed, so all you people down here have to behave well and only ask really easy questions. You can also tweet them, use the hashtag and my handle, so I will find them and I will come back to them during the talk. And you can also see the slides. If you go there, you will find them easily, and you can follow me. You can follow along, maybe easier. For this talk, you need to be proficient with Java 8. I'm not going to explain how lambda expression or method reference looks or works. I'm not going to tell you what optional off or map or flat map does. I assume you know that. So if that's not the case, then either settle in for a tough ride, or I just close my eyes and let you leave now. Okay, let's get going. First off, streams. Let's talk about streams. Who's been using streams? A little or a lot? That's, as far as I can see, everybody. Awesome, great. So everybody uses stream pipelines locally, usually. And then the question quickly arises, like, what can I use streams in my API? Can I return them or even take this parameters? And I think streams have some interesting properties when it comes to that. They're unmodifiable. So unlike lists or collections that I return, I don't have to worry that the client modifies them. Even if I use something like unmodifiable wrappers or immutable lists from Guava, there's still the possibility that he calls a method and then gets a runtime error. So if I return a stream, I can clearly communicate that there's just no way that this is going to be mutated by the client. It's very easy to transform them. And if you're like me, then if you have a small list, and then you go over the list to change a little bit, and then go over the list to change a little bit, even if it doesn't hurt performance because it's just a dozen elements, it still feels wrong. And that is not true for streams. It's really easy, right? You can transform these streams from one to another without worrying about that, which is because they're lazy. So I think it's a good way to start with some data that you have and then enrich that from call to call. Maybe something like this. So here you have two maps, which map from some user ID to user or to address. And then you can have methods that make it really easy for the client to first get the users. This is kind of trivial. But then this method could be in the same class or could even be a different class. It could be one class having the first map and this method, and another class having the addresses and this one. So you can easily say, I get the users, and then I map them to the addresses and combine them. Again, which is something that with list might feel wrong or wasteful. You can go further. So let's say now some other class has a map from addresses to lists of orders, and we want to have a stream of deliveries. We can get the addresses, and then access the orders by address, get all the orders for the address, and then map it to the delivery. So again, we can make just a slight improvement, go from users to users with addresses to deliveries without worrying about any meaningful performance impact. So I think this is really a good way to use streams. And but there are a couple of things you have to remember, right? So streams can only be traversed once. So this becomes kind of like the bottleneck to these APIs. You have to look out that you don't accidentally try to traverse the same stream twice. So the ideal version of this is that you only return streams where you can infinitely recreate them. Like from a list, you can always call list stream. Whenever someone calls that method, you always get a new stream back that can be used. Could be different with files maybe, or some other source that you can only stream over once. That is the case, then this gets more complicated. What happens if you do this extensively, which I discovered firsthand, is that at some point you might stream over something, and then 2, 3, 4, 5 classes later, during the stream, you accidentally mutate the original collection. With the list, this will not matter, right? But if you have a list on each layer. But if you have a stream on each layer, this might happen. So you have to really look out to do this in layers and not go like full circle, which sounds easy, but it happens. Slight disadvantage is if you want to use parallel streams, then it's not easy to decide where to call that. If you have a local stream pipeline, it's really easy to decide I want to use a parallel stream because you see everything from stream creation to its consumption. But if you spread this across different classes, it's hard to decide where and whether to use parallel. I usually tend, if I do this, I tend to put it in the end, like where I consume the stream, because there I got the most information. So returning streams is fine. What about passing them as parameters? Again, streams can only be traversed once, and this becomes more important now because the caller must always assume when he puts in a stream that it will be consumed. And this is actually the error-prone part. Like a caller might pass a stream and then accidentally use it later, which will run into the problem that the stream is already exhausted. So the caller must always assume that the stream is being traversed. And this is easy if you have something which obviously consumes the stream. Other methods might not be so clear-cut. It is possible, though, that you just transform the stream and return it back. So there are two examples for both here. The first one is kind of obvious. You have a method addUsers that gets a stream, maybe because some other API returned a stream. So this is the easiest way to pipe the stream back into some data structure. So you have some thisUsers, which is maybe a list, and you just add the users you get from the stream. And it's easy to see from calling addUsers that the stream is going to be consumed. The second is an example of transforming a stream. You pass in the stream users, and you get back another stream. And this is something that could be debated, whether this is really a good idea. Because here, you have the exact problem that actually the stream is not consumed. You pass in the user stream, but it's not consumed. You could easily call the user stream later in the calling method. Sometimes it works. If the stream that is returned here is used, it doesn't work anymore. So this becomes error-prone. So I think looking back over using streams here, I would say that returning streams is great. I can only recommend that, trying to slice things in more detailed layers, which allow you to add information gradually. And the fact that they're unmodifiable is really a boon here. I try to implement as many things as possible immutably, or otherwise in a way that I can control who modifies, especially collections. And this is a really easy way to do that with streams. So preferably do that if the streams can be recreated, so you don't run into the problem that a client gets a stream and doesn't know whether he can get another, because some method internally might consume the stream once. And this can be used to gradually enrich the data, as I said. So what about passing streams? We said that the caller must always assume the stream is traversed. This works well for obvious consumers. And transformations can be hard to track. And if you consume a stream or traverse stream, never ever return it. It's obvious, but again, it might accidentally happen. So last one, streams can only be traversed once. Look out to not mutate during traversal. And don't make chains too long, because it gets hard to debug when you enter like 5 different methods, which add maps and flat maps and filters and all kind of stuff. And in the end, you have to have all this in mind when you see the result of the stream. So don't go overboard. So you have questions regarding using streams and APIs as return value or passing them? If you have, you can just shout them, because I don't see anybody raising hands. No? Great. Did you fall asleep already? Exception handling. This is really great. Streams and exception handling, they don't always cooperate well, especially with checked exceptions, of course. And initially, this might seem like a shortcoming of the API. Like, why can't I just use checked exceptions? It would be so everything would be so easy. But due to the stream's lazy nature, this is not at all trivial, because if you add a map, for example, and the mapping method can throw an exception, then you have to encode this exception in the stream's type somehow, so it knows when you consume the stream that this exception could be thrown. So I think as a way to simplify the API, that's my guess, they can't accept exception throwing maps and flat maps or filters or whatever. At the same time, this gives us a good chance to up our skills and using more advanced techniques. So let's start with the problem. The problem is I have a method here that parses a user string to a user, but it throws a parse exception if something goes wrong. And then I have a method that, as we discussed earlier, he gets a stream of strings, maybe from a file or whatever, and then wants to return a stream of users. So the obvious solution would be this, right? I take the stream of strings, map it to users, return it, done. But I'm throwing a checked exception, so this doesn't work. So which options do we have? How do we get around this? And the most basic one is this one. You all know that. You just, sorry for the formatting, it's hard to fit all this code on slides. You just do a try catch in here. And then later you might want to get rid of those null objects that you put into the stream. So first of all, this is super ugly, right? We like streams because they're concise and you can see what's going on, and this just explodes the whole stream pipeline. And this is like, I hate seeing this. At the same time, it's not really doing a very good job. It's creating null objects that you later have to filter out. You have to handle the exception locally. Like in this spot, you have to know what is the best way to handle this exception. And if you're returning a stream, chances are that maybe the caller different callers will use this method, and they will each have their own way to handle the exception. So handling it here can be tough. And then also the troublesome elements are just gone. Like some strings couldn't be parsed, and the only thing you will see are maybe long messages, and that's that. So that's not ideal either. So there's room for improvement. The first one tackles the ugly part. We just put it into a method. We just stuff it in here. We do the same thing as before. That's less ugly, which is nice. But at the same time, it makes a distance between this cleanup step and where the cleanup is required. Like here, I create the problem, and here I have to fix it. It makes the distance greater, which can lead to problems during refactoring. But you still have the same problem. You have to handle the exceptions locally, and troublesome objects disappear. If you Google for this problem, the top Stack Overflow answer contains this thing. So the idea is to trick the compiler. I think I use the scare quotes because actually you're tricking yourself or you're tricking your colleagues. You're getting a method that is like this checked function is like a regular function, but it can throw this kind of exception here. And the idea is obviously parse matches this, right? Parse gets a string, creates a user, but throws a parse exception, so it somehow matches this. And the idea is to get a function out of that which does not throw. And the idea is here that I create a new function with a lambda expression, taking whatever element I get, trying to apply the function. If it doesn't work, I use this sneaky throw thing. And the sneaky throw thing is you can use generics and suppressing unchecked warnings. You can get the compiler to not find out the fact that you're actually throwing a checked exception. You can look at this implementation online, but I'm not recommending this anyway, so I didn't show it here. With that, I can do this. I can now say, I take this parse function, pass it into hide exception, and then it just disappears, right? So here now this compiles. But I think this is a horrible idea. I would ask anyone to never do that, because you effectively get a stream which has a bomb in it, which can export at any time, which is true with any kind of exception. But here, I can't even try catch it. Because if you try catch a checked exception that is not declared with a throws clause, you can't. The compiler says that this exception is not happening. Why would you catch it? So then the caller has to do a big try catch all exceptions. And also with runtime exceptions, you would do this with runtime exceptions. You also hide an exception throwing thing in the stream. But the idea with runtime exceptions is that they mark implementation errors, right? But this is a business exception. It tells you that something, not the program is wrong, not the code is wrong, but just the data didn't work out, which is not the kind of stuff that you usually put into runtime exceptions. So this is wrong on a different level. So I would say never do that. So now we come to runtime exceptions. I can do the same thing again. I wrap in the unchecked exception by catching it here and then just wrapping it in a runtime exception. Now it looks like this, very much like before, and it's gradually better because it's not this exception that I cannot even catch. But still, the stream executor has to handle this exception. It has to know that the exception would be thrown because of a business problem. So it kind of like has to be in the documentation of parse that look, there's an illegal argument exception that can fly that actually you must handle. So this is not ideal either. And like before, by the way, the exception aborts the stream pipeline. So the first wrong the first element that cannot be parsed aborts the whole pipeline. I usually consider that not to be the best case, not to be the best solution. Okay, next thing. We can remove the troublesome objects. This optional is one way to do this, but the idea is that we, again, get this function that can throw an exception. We try to execute it and return back an optional if it worked and an empty optional if it didn't work. Then we do this. We call map, and then we get back the stream, which now contains optionals of users and not users anymore. Now we can check whether the option is actually present, and if it is, we get it out. So we remove those elements where the parsing failed. This also requires an extra cleanup step. We had that earlier with null. I think this one is better because the other way I have to remember that there could be a null in the stream, and the type system is not helping me here. Here it does, the type system helps me. When I return without this map, the compiler is complaining and says, look, you have a stream of optional user, you can return that. So here I can then get the compiler helping me in saying I have to remove the optional wrapper. So troublesome elements disappear. Again, generally, I don't think that's the best solution. So let's go one step further. We've now more or less exhausted what the JDK classes can provide us with. So it gets one step further. Let's do something which is a try. Who knows what try does? A few people. Okay. So a try is very similar to an optional. An optional has either some value or no value. And these two states, a try also has two states. It either has something that worked or something that didn't work. So you get, when you try something, you can, like here, you can say try off, and then you do this, execute this. Then try will execute this immediately, and if it works, it will go into the success state, and you can return the result of that operation. And if that doesn't work, if that throws an exception, it eats the exception up and falls into the failure state. And then later you can query which state it is in, or much like with optional, you can then map or flat map or do whatever you want on these results. So you create another util method, which again has the goal to go from this checked function to a normal function. And this time we just take the element that we get and apply this function, which throws the exception. And try will then catch that and go to the success or failure state. So doing that, we can again start with our stream of strings. And then we add the parse function. We pass that to the wrap try, which executes that and wraps it in a try. And now what we get back is not a stream of users. That's like the first time we don't have a stream of users. We have a stream of try of user. And as I said, this requires an external library. But what I like about this, I use Java slang, but you can use different functional libraries which do that. This encodes the possibility of a failure in the API. Like the caller will now be aware of the fact that things might go wrong, and he will get a stream of all the things that happened, and none of them are missing. So he will see whether all of them failed or some of them failed, and he can decide whatever. Now the caller can decide that if one try fell into the failure state, I want to fail the operation. I want to try to recover, or I want to ignore, or I want to lock, or whatever. So this is a great way to tell the caller of your API that something can go wrong. By the way, you can also do this with optional. Like the earlier example, you could have returned a stream of optional, which would also have told the caller the same thing, something can go wrong. But then he has no chance to see what went wrong. Some optionals are just empty, and he doesn't know what to do. He can still fail the operation, but he has no way to recover what went wrong and which element went wrong, for example. But here you do, because you get a try which contains the exception, and unfortunately the exception is contained as an exception, like as this type, or even as a throwable in some implementations of try, which is a problem. But you could then cast it to a parse exception, and of the parse exception you can get out which string actually went wrong. So you can still recover the elements that failed, which is a great property. We can go still one step further to address the last problem with having the exception as an exception type. You can use either. And again, either is like optional and like try. It also has two states, left and right. and also allows them to process them further with maps or flat maps, or other kind of functions like these. It is parameterized in both types, though in L and in left and in right. And usually, when you use that to encode error cases, you use the exception on the left and the success on the right. So what we do now is, again, we take this function that can throw an exception, and then we try to apply that function to an element. And if it works, we stuff it into either.right, because, hey, everything worked. And if it fails, we take the exception and stuff it into either.left. So this is kind of like catch the exception and stuff it into a failure state. This is what try does. The try-off function does this for us. For either, we have to implement it ourselves. But it's the same effect. If it works, go to one state. If it doesn't work, go to the other state. In this case, right for success and left for failure. And this is what it looks then. You take a stream of strings. You wrap it into this either thing, the parse function, wrap it into either's, and you get back a stream of either of parse function or user. And I find this, for this particular case, by far the best solution. Because again, it encodes the possibility of failure in your API, which makes it easy for the caller to access the precise error. Because you can now get the parse exception, which tells the user very clearly what can go wrong, and then you can go, take the parse exception and use the getter to get the string that failed. So this, I think, is the best way to approach this particular problem. When you have a longer chain, and you can have several different exceptions, then this quickly escalates to either of exception. Because if you don't have a current super type of two exceptions that might be thrown, like a find not found exception and the parse exception, then, like an IO exception and the parse exception, then you have to go to exception here. So that's not ideal. Then maybe the try is easier. But for this case, I think it's a great solution. So to reflect on the exceptions, I recommend everybody not to be smart and try to trick the compiler. Actually, I want to leave a comment on the Stack Overflow question at some point, because the guy gives a different solution and then says you can also do this, tricking the compiler thing with the sneaky throws. And it's not even his primary solution or his primary recommendation, but it's still upvoted like 100 times, and people might be using that. And I think that's plain horrible to do that. Whatever you do, don't return nulls in a stream. This is really going to bite the people downstream. So if you say I don't need the troublesome objects, I can just keep them out, then do keep them out. Don't map them to null and leave them in the stream. And I would highly recommend to use types which express the fact that there can be a failure, try or either. So while streams don't cooperate well initially with checked exceptions, this gives us the chance to use some functional concepts and make the code better. Because now, if streams were handling checked exceptions the easy way, then we could just parse our thing, and when it fails, it would likely fail the entire stream once the first exception is thrown. Something which I find usually when I use streams, I never want that. I rarely ever want that the whole stream fails because of one element. And these more functional concepts like try and either give you the tools to let the entire stream run and decide later what you want to do with errors. Questions for exception handling? No? Okay. Finding elements. This is really simple, actually. But I don't know. I fell into that trap once or twice, and it kind of annoyed me. So everybody knows what find first and find any do, right? You have a stream. Maybe you just filtered it, and you just say find first or find any, and you get some element back. And if the stream has an encounter order, which means it comes from a list, for example, find first actually returns the first element. And you also often use it after you filter, and then you say find first or find any. So this is the typical example. We can actually start on the bottom here, where you can see the loop. This is the typical way to do this with the loop. You say I loop over users, and as soon as the user ID maps the get us wrong here. As soon as the user ID maps the ID I'm given, I just say, look, I found my user and return it as an optional, or if I don't find anything, I return an empty optional. And the stream does exactly the same thing. You stream over the users, you filter all those users and throw those away that have the wrong ID, and then you say find first. So far, so good. So let me be clear, find first and find any themselves don't do anything wrong. They do exactly what they say they do. But I usually often, actually I said sometimes here, but that's kind of like an understatement, I often see that the code, the stream pipeline that was written there depends, the correctness of the code depends on the fact that only one element will survive the stream. The ID was a good example. But there are no checks around. With the IDs, it is possible that there's a map somewhere, and as soon as you enter a user with the same ID again, some error happens and things blow up. So it might be possible that you have other safeguards in place that make sure that what you filter by can only be there once. If that is so, then that's fine. Then you're no trouble. But often I see this used with ad hoc filters. Like somebody says, like, look, I want to filter, I get this JSON stuff, and I want to filter by this property. And then you just say find first, and then you will get any element back. Like you don't even know which one you're getting back. And this might be different from system to system. Maybe you're iterating over a set. So this might be different from platform to platform that you're running on. And this makes the code unpredictable, and also makes it misbehave in kind of like a subtle way, because nothing's really breaking, right? You get a user back. That's fine. I get the user back, and I do stuff with that user. But if I don't do the stuff when another user is mapped to the same ID, then maybe I should process that one too. Or maybe it should not even be there. I am a friend of fail fast, so something should happen here, instead of silently doing something that might not be what I want. So the easy solution to use find first and find any might not be the right one. At the same time, this is not a property of the streams. Like the loop I showed you earlier, which is by far the most common way to solve this kind of problem, has exactly the same properties. So, making sure that there's only one element there. It would be nice, it would be a find only element, a find only method. It's not there though, but it's really easy to create it. If you've ever used reduce at the end of a stream, if not, look at it. Reduce is cool, you can do some interesting stuff with it. Reduce just means take the first element, and then when a second element comes, combine it with the first. You get a result. Then take the third and combine it with the result, and the fourth and combine it with the result. You're giving a binary operator which takes two elements and maps it to the next element. If you do this implementation, what happens is the stream will take the first element, and as soon as the second comes, it combines it with the first, and you get a legal argument exception. Or you could use something else, but whatever you use. So this way, you get an exception as soon as the second element is passed to the reduce function. So this way, you can say, I want to filter by user IDs, as I did before, and then I reduce to only element, and now I'm sure that there's only one element. If there's more than one, the stream pipeline fails with a legal argument exception. So there are like two things I like about finding only. First of all, it fails fast. I said that I think that's generally a good practice to do that. But it also expresses intent pretty clearly. You can see reduce to only element. It tells the reader of that code what your intention are. If I see a pipeline that ends with find first, and I wonder, like, what about the error case? It doesn't really tell me that, because I know that people misuse, not misuse, but use find first in ways sometimes in which they shouldn't. So when I see find first, I'm not sure what exactly is meant. If people would reuse something like reduce to only element consistently, then I can be sure when I see find first, or find any, even more expressively, I can know, like, the caller really doesn't care if there are more streams and more elements in there. There might be more elements in there, and the code is still okay. If I see reduce to only element, I clearly see there must only be one. So if some misbehavior happens, it's easier to debug. The downside of reduce to only element is it processes the entire stream. So if we look back here, if we have like 1 million users, and the filter returns only one, if I use find first, and the second user is the one I want, I'm done. And I never process the other 999,000 something elements. With reduce, that doesn't happen, right? Every single element of the stream is dragged through the filter, and most of them are discarded, hopefully all but one. So in the case that everything works as planned, I process the entire stream. So if performance is a consideration, that this might not be ideal. In general, I'd say correctness trumps performance, but some Twitter discussions make it appear that not all people agree with it. So my summary of what we just talked about finding, if you have an ad hoc filter and the correctness of the code depends on the only one element surviving that filter, don't use find first and find any. Use a reducer. You can actually use a collector as well. There are various ways to handle this. It comes with a performance penalty, but by and large, I think it's worth it. And if you have the slides in front of you, you can click on this, and you will find more obnoxious writing by myself about that. You have questions? No? That's weird. Like, are Swedish people not asking questions? Who is not from Sweden? Okay, people, like, you can ask then. Okay. Stream performance. Not going to happen. I'm going to run out of time, so I decided to not talk about stream performance. There's a great talk, which makes this superfluous anyway, by Stuart Marks and Brian Getz, two people who have been implementing streams, so they know way more about it than I do anyway. They have a great talk, Thinking in Parallel, from the last Java 1. The first part talks about the approach to programming with the streams, something I would also have liked to present, but they do that very well, obviously. And then the second half talks about judging performance, guessing what the performance might be. And I can highly recommend watching that talk. It's really great, so I'm not going to repeat that here. So if there are any other things that you always wondered about streams, some problem you had or something else, I'd be happy to hear about it. I'm not going to ask you to ask that now, but you can maybe tweet or write a mail or something. I always want to expand the kind of stuff that I deal with in this presentation. So if you have something that you always wonder what would be a good solution, send it my way. Maybe I can help. Let's talk about optional. Optional is everybody's favorite bike shed. It's awesome. It's so simple, and because it's so simple, it invites so many different opinions. And there are people like me who run around all the time, like every conversation. I can drag every conversation to optional really quickly. It's awesome because you don't have to deal with actual complex topics, right? Somebody comes with a business problem and it's hard, and then you just come down to you should have used optional everywhere, and then you get a total different discussion, which is much easier. So if you want to do that, if you want to be part of that discussion, I can recommend to you talk about usage patterns. But I want to make sure that I present something else later as well. So of these 3 topics, I want to tackle only one now. And I want to make you choose. So what do you want to hear about? Like usage patterns of optional. Then optional is a value-based class, whatever that means. I can tell you about that. Or optional is not a monad, whatever that means, but I promise there will be no math. I can explain it without math. So who wants to see what usage patterns of optional? Oh, looks like almost half already. Value-based class? Much fewer monads? Oh, okay, let's see whether we can come to monads. Surprise second place there. Then let's go to optional faster. Some basic rules. Whatever you do, don't call get without calling is present. No matter how sure you are that there must be some element in there, never do that, please don't. Generally prefer this mapping and flat mapping things. Flat map and map can take exceptions, right? The same with streams. Here, it's easier to do crazy shenanigans because optional is not lazy. The operation will fail then and there. So you might, you can do some optional, you can get an optional, you can map it later, you can return it later. And because it happens immediately, you might get away with throwing some kind of crazy acceptance there. Everyone who sets optional to null, like returns a null instance instead of an optional, you have to punish them somehow. This is not acceptable. Actually, like I think at least IntelliJ warns about that. I'm sure other tools do too. Then also, I am a fan of optional, as you will see later, but still don't do this kind of thing. Like this is really, really cool and hip, but this is easier. So don't end up with ridiculous optional pipelines just because it's cool. I did that, I had fun, like I was convinced it's not a good idea. So now we have a wide variety of different opinions. From people who say don't use it at all, unless you have to because it sucks, to people saying like use it everywhere because it's awesome. I want you to make up your own mind about that, so I want to try to present all these approaches in equal footing. Okay, so people who say don't use it, they have a couple of basic assumptions. Not so few, actually. First of all, they say the API is verbose and it invites misuse, like what I showed you on the slides before. Stack traces are harder to debug, right? Because then you're somehow in a lambda, in an optional class, instead of just a simple if or for loop. It's not serializable, that sucks. So you can transport it over the wire easily. Various frameworks don't support it well, use it as fields, for example. The constant dereferencing of a single of an additional instance, like you don't have a user now, you have an optional of a user, which means you have to go to the memory address of the optional, and then you have to make another jump, maybe another cache miss, to the user. Reduce performance. And then you also have this additional instances lying around. You don't only have the user, you also have the optional of user, which means the optional is there as well, eating up memory. And you just use null handling, like every sane person does. All these drawbacks come without benefits. So their conclusions is optional sucks. Don't use it if an existing API returns it, and then try to back out quickly and get on with your life. These are some of the people who think that, and I have a high opinion of them. So they're wrong here, obviously, but still. And I actually also asked them the permission to put their names on here. But if you want to pick a fight over any of these kind of opinions, I put all the names up there so you can find them. Okay, so then what else can we do? What else is a value approach? There are a couple of different assumptions. So it was designed as a return value. Yeah, it's right, it's not serializable. And indeed, long-lived instances can increase memory consumption. Short-lived instances, like return optional and then unpack it immediately, are very likely to be caught by inlining and escape analysis. So there will actually never be an instance. So that would be for free, basically, speaking from a garbage perspective. And boxing arguments, like saying I have an optional argument for a constructor or for a method, and then I have that thing, like I have a user, but the method takes an optional user, then I have to wrap it, and that's verbose, and nobody wants to do that. So the conclusion is, use it as a return value if the return of null would be very error prone. And this is exactly the way why it was introduced. It was introduced as the tail end of a stream pipeline, because if you call find first on a stream and you get null back, then you're bound to do something with it and get null pointer accepted. So it was meant for places where null is returned and the user is very likely to call additional things on that. So only use it for that. No instance variables, no parameters, and try to stick to short-lived instances. People having that opinion are against Stuart Marks, Brian Getz, two people who developed this class. So if you come away with this is too complicated, I want to participate in this stupid discussion, take this option because it's a great default. It's a basic recommendation. So then very, very similar, not limited return values, but return values. The idea is returning null is always kind of error prone. So why not always return optional? Unless you've found out by performance benchmarking that you have a problem somewhere. So the idea is to use it as a return value whenever, but don't do the other things. No parameters, no fields. And Stephen Colburn of Joda time fame, which is also, I'm not sure whether he's here, but he's also at the conference. He has, that's his position basically. So then comes the right choice, which is null handling always sucks. Wherever it happens, as a field, as a parameter, it doesn't matter, it always sucks. Use optional everywhere where that happens. I want to add the caveat, the first step should always be, and this applies to all of these things I just said, try to avoid using null at all. The idea of value might or might not be there. Try to avoid that assumption. But if you have to make it, if design does not get you around that, then my advice would be just use optional everywhere. Because it makes sure that the type system helps you with your null problems. The type system will tell you, look, this thing might be there or might not be there, deal with it. If you want to go one step further, maybe you use something like try and either for other cases. So I found this to be awesome because it means every single null instance I find is immediately an implementation error. I never encode a valid state with null. So whenever I find null, I know it's wrong. Right out the gate, I know I just have to get rid of that null instance and I'm done. I never have to find out why is it null. Is it on purpose? Like did something fail and I want to continue, or is it like optional? Maybe it's a user input, the input that was supposed to be there. Type system helps. And yeah, performance, I know. Unless you have performance requirements and a benchmark showing you that you don't meet them, and you see that optional is the case, unless all of these apply, I don't pay any heed to performance argument. I have to admit, I never worked on high-performance applications either, so maybe that's the reason. So again, I just said that. Avoid the whole concept of optional things by good design if it works. Otherwise, use optional. And I'll come to the third point on the next slide. People who say that are not only me. There's like one other guy who has the same idea. Mario Fusco does a lot of functional programming in Java. He shares that opinion. Regarding the overload, people complain that if you have these methods down here, you have a bar method that takes the drink and another bar method which does not take the drink. But now we have an optional of bar. Optional of drink. What do you do? Like you want to call either this or this method, right? If you have an additional overload, you can make you can give clients that have an optional a third method to call with their optional. Same thing the other way around. If you only had this method, we would take the optional argument and do whatever, basically implementing both of these. Then some people might have the drink, and some people might not, and both of them have to create an optional wrapping either nothing or their value. So if that's a problem to you, this could be a way to go. It's weird, though, having 3 overloads for the same thing, but it works. It also explodes quickly when you have a couple of optional parameters. Don't do that anyhow. So I don't like that either. So reflection on usage. Do what I told you, but otherwise make it a team decision. This is something that can get off hand quickly. People have different opinions on this, and then they do vastly different things in the same code base, violating all kinds of assumptions. So whatever you do, and as I said earlier, if you're not sure, pick the default, pick the JDK recommendation. Make it a team decision, put it in your code style, enforce that code style. Make sure that you do this somewhat consistently over the code base. Learn over time. We started with only as a return value and then went to maybe sometimes it's okay as a field because it just proved to be the prudent case and prudent thing to do in some cases. And be aware that it's easier to relax the rules than to make them stricter. So if you start low on the what is allowed scale and then go up, it's easier than the other way around. Many additional sources. As I said earlier, people love this topic. Great, value-based class, nope, not a monad. Okay, default methods or not a monad? Okay, let's go with the monad. So ignore this jibber-jabber. For a monad, this should always be true. I call optional of nullable, and then I get something, and then I flat map that with a function. That must always be the same as if I use the function and then apply x to it. The function takes an element and returns an optional. So this thing returns an optional. And this function takes an element and returns an optional. You can see an example of this here. The function, whatever it takes, whatever it gets, it just returns an optional of mango. So now I make an off nullable of null, flat map f. But because the off nullable of null is empty, flat map f gives me an empty optional. If I use f and apply it to null, I get optional with a mango in there. So for optional to be a well-behaving monad, this would have to uphold, but it doesn't. If you use null here, then things go wrong. We'll come to why that is bad in a moment, but things go wrong. This case is maybe even more clear, makes it easier to guess why things could go wrong. So there's associativity rule for map. Again, this should be true. I take a value, I map it with a function, I map it with another function. That should be exactly the same, like taking these two functions and putting them together in one function, and then mapping the value from there. So I have two functions. The first one maps everything to null. The second one maps everything to mango. When I start with a key v and map to null, I get null. The second map is not applied, empty optional. If I start with a key v and then combine f and g, this combination maps s to null, but then g is called, and g doesn't even look at the null here, it just returns a mango. So f then g maps from s to mango, so I get an option of mango. So again, not the same result. Why? Optional maps null to empty. And then flat map and map are not executed in empty optionals. So as soon as you fall into null, the rest of the pipeline is not executed. So why should I care? Because refactoring can change what kind of code is executed. If you did functional programming, then you will now be like, oh my God, why? This is horrible. Because as a functional programmer, you use these kind of concepts that you can just take methods apart and put them together without that changing the flow of the system. But now it does. If I have a map that does something big and decide, I can separate that in two small steps, like in one map and another map. And this might break, surprisingly, if some null popped up in between. So when functions have side effects, which they shouldn't have in general, then this is even more error-prone. So what does it mean? Optional is no well-behaved monad. That being said, I don't see that as a weakness. If you have a well-behaving monad, then it means that optional would have to pass null. There would be optional empty, and then there would be optional with an element, but null would be a possible element in this not empty optional. So then optional would occasionally pass null into the functions that is used for mapping. And I don't want that. I want optional to help me avoiding null. So I think the way it is implemented is actually doing its job well. But it's almost a monad, but not quite, and that might cause confusion. So see it as a way to avoid handling null instead of a cool functional programming thing. And see that refactoring can cause problems. And here are two posts who explain that in more detail. Okay, 5 minutes left. Let's see. Is there an option to optional? Was the question. Is there an option to optional? Sure, that's a trick question. Uwe Lindström, I'm not going to answer that. If you're here, come to me later. Otherwise, tweet again, angrily, if necessary. So quick thing about interface evolution with default methods. Default methods were introduced because the JDK team wanted to add methods to interfaces like list. If you add a method to an interface, then all implementations usually, like without default methods, all implementations of that list break. Not a problem because the JDK team has, of course, control over array list and linked list and other implementations it has. But alas, it doesn't have control over all the other list implementations. So if you're in a position where you're providing interfaces and you're not the one who has all the instances, because clients of your library or your framework are supposed to create instances as well, implementations as well, then you have to have a way to add methods without breaking their code. And default methods were the way to go. You can add a default method which can have some code in it, and then the client can just implement the new version of the interface and nothing breaks, because even though the method is on the interface, it already has the implementation. And then he can override it they can override it if they need to. So that's great for adding methods. What else can we do? So in general, if your clients are expected to upgrade their code over time, which is almost not true for the JDK, but if you're in a position that you say we're releasing version 5, and then throughout all of version 5 you can update your code, and then we might make a breaking change in 6, then this could be a way to go to do various things like adding or removing methods. So first of all, there's always this kind of like 3-step thing. You release a new version of your library that kind of contains the old and the new. And somehow default methods are used to ensure that works. Then you have a transition phase where your clients move from the old interface outline to the new one, like removing old methods that aren't there anymore, that kind of stuff. And then you have a new version that gives the new outline, that has removed the old outline, only contains the new one. So let's start with adding methods, what I just described basically. If a reasonable default implementation exists, you just add the method with the default implementation. If you have implementations of that code, you just override the implementation if you want to. And if you have callers of that code, they can already call the new method. And then external callers can at some point use the method and maybe override it, whatever. So if there's a reasonable default implementation, you're fine. It's the easy case, the one that happened for the JDK, mostly. If no reasonable default implementation exists, if there's just nothing sensible you can put into the interface, you have to go quite a different route. You have to add the new method, but it should throw something, maybe unsupported operation exception. Then you override that method in all internal implementations. Then there's a transition phase where the client updates his implementation on his callers. And then later you can make the method abstract. And then only can you call the new method. Because if you start calling the method, oh, damn, doesn't fit here. He said internal callers use the new method. If you use that too early, if you start using the method here, you're running into your own exception. So you have to have a whole release before you can start using your method. You add it here, but not use it, and the clients make sure that they implement it properly, and then you can start using it. You can do that for removing methods, where there are external implementations or not. You can do that for replacing methods, blah, blah, blah. But we're not going to do that in detail. So in general, if the client can be expected to update their code, then you can use default methods to slowly evolve an interface by adding, removing, or replacing methods. And the mode is always the same. Do it in your version, give the client time, then release a version with a new outline. And if you want to know more about that, you can read that post. If you think about documenting that choice, which I can recommend, you can use the new Java doc text, which came in Java 8. Great. I never introduced myself, because I always want to start with the interesting stuff before I come to that. So my name is Nicolai. You can find me here where I blog. You can find me here where I'm the editor. Twitter, and I never use Google+, but if you have to, you can do that as well. And I'm currently writing a book about the Java 9 module system, and we're also having a course on that in Zurich. Yeah, so if you go in Switzerland by accident, in April you can go there. Oh, I remembered, I forgot to update the slide. We also have a course, a workshop on all that I just said in February in Vox Days Zurich as well. So if you want to learn more about that and more content and in detail and with hands-on guide, look up the Vox Days Zurich homepage or get in touch with me. It would be great to see you there. Thanks.